In this lesson, we discuss further about how the internet works and the history of the internet and specific mechanisms that allow the internet to do its functions. So in terms of what is the internet, it's a global system of computer networks or a network of networks. There's very popular protocol suites, TCP/IP, that we'll discuss and mention later. And the whole idea of the internet is to be able to provide services and information resources across devices that are distributed and connected throughout the internet. In terms of examples of services that you can find on the internet, some common things that we use almost every day would be things like the World Wide Web, being able to use a web browser and using HTTP, hypertext to be able to locate and search web pages, certain kinds of communication, instant messenger, and other kinds of messaging services, and also data transfer, so transferring files using services such as FTP that we'll mention later. These are all the kinds of services that we do when we access and use the internet. So a little bit of the history of the internet in terms of how it originated and grew to what we now have. It all started with ARPANET, the Advanced Research Projects Agency Network. It was one of the first operational packet switching networks. And the goal of ARPANET at that time was to be able to function even if parts of the network were inoperational. So if we have a certain segment of the nodes that are on the network go down for some reason, messages could still be delivered. And this is very useful because, power outages or other kinds of things that might affect the network, if that network can dynamically alter and adapt, then that's a very powerful feature. And it's also developed in terms of its functional purposes to allow scientists to collaborate in a distributed way. And the internet became functional in 1969. And there were 4 basic nodes shown here at the UCLA, SRI, UC Santa Barbara, and University of Utah. So a node, just a host, is any computer that can directly connect to a network. So initially there were only 4 of these computers, and a node can store and transfer data and messages and pass messages on to other nodes and eventually deliver messages from one host to another. And the original 4 here noted grew into a much larger size, as we'll discuss. If we look at this particular slide, when it mentions that there were 4 host nodes in 1969, that in 1984 grew to thousands of nodes, and today there's like over 7.3 or so billion nodes on the internet. So being able to grow within under 50 years to such a size attributes to how prevalent and present internet is in our lives, from all kinds of topics such as devices and very, very common everyday things that now are connected through the internet. So the Internet of Things is a popular phrase that's being used. So the World Wide Web, also known as the web, was created by Tim Berners-Lee as a way to connect scientists together. So the idea of hypertext is being able to make connections among documents through things that have relations. So if one word is being used in a document, you can click on that document and take you to another document that defines and elaborates on that topic further. So it has built-in connections to other documents, and really a website is just a collection of web pages, and those web pages may themselves refer out to other web pages. A word that's often used when we reference the World Wide Web is a URL, or a Uniform Resource Locator. So a URL can be thought of as a way to specify a unique location or address for some kind of resource on the net. A web browser, for example, retrieves a web page by using the URL. And the URL can have many forms and access many different kinds of resources. So as you can see on this page here, if you look at the components of a URL, there's the actual protocol in which that resource is being accessed. Here it's HTTP, the Hypertext Transport Protocol. Others could be FTP or other variants. And then the domain name represents a location or an address where that resource can be found. And then the path is a more refined location of that resource within the particular domain that hosts it. So how the internet works. Another very important topic that your students should know is that of the Internet Protocol and IP addresses. So an IP address can be thought of as a number that uniquely identifies every computing device that's connected to the internet. And it's composed of 4 groups of numbers. Each one of those numbers is a byte in length 0 to 255, and each separated by a period. This IP address can provide the location or an address of a certain computer. So anything that's connected to the internet would have to have this. And sometimes they're statically assigned, that is, they're given an address and the address is constant for a time, or dynamic. So connecting to the internet, you may retrieve a dynamic IP address that the next time you connect to the internet, it might be a totally different address. So looking at the contents of an IP address, the first part identifies information about the network, and then as we move down those four numbers, we get more specific about a particular type of computer that's being referenced by that IP address. An IP address is very easy to find. If you open up a web browser, you can just go to Google and type what is my IP. So here was a slide that was found where someone did that and captured the screenshot, and you can see that person's IP address showing right there in the result from Google. So you can try that, and students can know, whatever computer they're on, what particular IP address they have. So you could even ask students in the same room to do this and then compare, what are the differences in numbers between the IP addresses that the students see within the same room. So the idea is that IP addresses are very useful and are needed in the internet to be able to locate certain resources and computers, but they're not very human friendly. So being able to memorize a whole bunch of numbers would be similar to trying to memorize many different kinds of phone numbers, and even worse than just trying to memorize your close friends, because every web page you would want to use, you'd have to know the number for that particular resource or domain. So what a domain name is it's a textual version of the IP address that's much more understandable by humans. So the components of the domain name are separated by periods, and each domain name can represent one or more IP addresses. So a service called the domain name system helps to translate the domain names down to the IP address, so that we as humans in a web browser can type a certain domain name, and a DNS can then help provide the specific IP address in numeric form that is needed for the internet to be able to locate that. So for example, a specific IP address on this page would map down to a specific domain name. So the top level domain abbreviations represent different types of organizations that are associated with specific kinds of domains. For example, .com is commercial organization, .edu is an educational organization, .gov is government, .mil is military, and so on, and .org would be originally was a nonprofit organization. There's others such as .info, .biz, and others that are being proposed. But this is just an abbreviation. It kind of gives a suggestion on what kind of organization is being represented by that domain name. For example, Microsoft.com or Google.com. So how does the internet work in terms of who controls the domain name? The Internet Corporation for Assigned Names and Numbers assigns and maintains these top-level domains, and a series of domain DNS servers help to propagate whenever new domains come into existence on the internet. So as a new domain comes in existence, the actual IP address and the associated domain needs to sort of cache itself out to many DNS servers. That takes a little bit of time, but eventually that mapping between a domain name and the IP address becomes well known and translatable. So this is just an abstraction that shows different ways in which internet addresses and IP addresses can be used. In step one, the user asks for a very specific domain name. The request goes out to the DNS server that tries to then resolve that domain name down to an IP address. If that DNS server cannot resolve it, it may ask a peer DNS server or another DNS server that's nearby to see if it can resolve it. And if that third request, if that DNS server knows, then the one that does not know the mapping can update its own record of that. And eventually we resolve down to that textual domain name to the real IP address that will allow the client here in one to connect down to the actual server. So also very important to discuss, and this is also a topic of impact that you may want to have your students to consider, is who actually controls the internet. So for a long time, the internet was neutral. No one really controlled it. It was kind of a public cooperative agreement. So no entity controls that, but there's several organizations that do advise and define standards, such as the World Wide Web Consortium and Internet 2. These are all groups that decide what protocols and what kind of standards and guidelines are used, because everybody needs to at least agree on the same way that we're communicating over the internet in order for the messages and information to work out. In this next lesson, we will discuss topics about protocols, and in particular something called TCP/IP and another thing called UDP. But that's kind of the summary of the history of the internet, discussion of the World Wide Web, and some of the very basic parts of how the internet works.